This is the story of a genius, discovering arithmetic progression when he was a kid. Legend says a young Carl Friedrich Gauss was restless in class, chatty, fidgety, not exactly the teacher's favorite moment of the day. To calm everyone down, the teacher gave a busy work challenge: add all the numbers from 1 to 100. Most kids sighed and started plodding along, 1 plus 2 plus 3, thinking it would take forever. But Gauss looked at the list and noticed something clever. He imagined the numbers in 2 rows, 1 up to 100 on the top, and 100 down to 1 on the bottom. Suddenly, each pair lined up to the same sum: 1 plus 100, 2 plus 99, 3 plus 98. Every pair equals 101. And there are 100 such pairs. In seconds, Gauss had the answer: 50 times 101 equals 5050. What looked like a punishment became a pattern. The trick wasn't grinding through the problem, it was spotting the symmetry. And that same idea, pair to the average, then multiply by how many pairs, works for any evenly spaced list of numbers. We're building a list of numbers by always adding the same step k. Start anywhere you like. That first number is a0. To get the next number, add k once. That's a1 equals a0 plus k. Add k again for a2, and again for a3, and so on. Every step is the previous term plus k. If we keep going, the second to last term is an1 equals an2 plus k, and the last one here is an equals an1 plus k. That's all an arithmetic sequence means. Same step every time. Since each new term is the previous term plus k, so the nth term is the previous one plus k. Now replace the previous one with the one before that plus k. So we've added k twice. Replace again with the earlier term plus k, now we've added k 3 times. If we keep stepping back like this, we see the pattern. Every time we go one term earlier, we add another k. That means the nth term is the second term plus n minus 2 steps of k. And it's the very first term plus n steps of k. In other words, start with an initial value, then take the same step k again and again, n times, gets you to the nth term. Here is the ultimate problem. The total of an arithmetic sequence written as a0 plus a1 plus a2, and so on up to an. How can we calculate this sum? Can we use Gauss's idea? The answer is yes. Think of the classic 1 to 100 story. Pair the rows. 1 with 100, 2 with 99, 3 with 98. Every pair adds to 101, and because there are 100 numbers, you get 50 identical pairs, so the total is 50 times 101. Our question is the same idea in general. Pair first with last, make all pairs equal, count how many pairs there are, then take half of the total of first plus last times the number of terms. In more detail, write the sum backward from an to a0 under the sum of a0 to an. Start with a0 plus an. To calculate the sum of a1 and an minus 1, replace a1 with a0 plus k. Now it is an minus 1 plus a0 plus k. Replace an minus 1 with a0 plus n minus 1 times k. That gives a0 plus n minus 1 times k plus a0 plus k. Rearrange as a0 plus n minus 1 times k plus a0. Combine the k terms to get a0 plus nk plus a0. Notice that a0 plus nk is an, so the result is an plus a0. To calculate the sum of a2 and an minus 2, replace a2 with a0 plus 2k. Now replace an minus 2 with a0 plus n minus 2k. Rearrange the terms as a0 plus n minus 2k plus a0 plus 2k. Combine the 2k's to get a0 plus nk plus a0. Notice that a0 plus nk is an, so the result is an plus a0 again. For a general pair, take an minus m and am. Write am as a0 plus mk. And write an minus m as a0 plus n minus m times k. Add them, and the k parts combine to nk, with an extra a0 alongside. Recognize that a 0 plus nk is an, so the total is an plus a0, again. This implies that the sum of each pair on the top and bottom row is an plus a0. Here's the finish. We paired each top and bottom term to get the same total, an plus a0, and there are n plus 1 such pairs across the 2 rows. That gives 2 times s equals n plus 1 times an plus a0. This implies that s equals n plus 1 times an plus a0 over 2. That's Gauss's idea in general for any arithmetic sequence. I hope you enjoyed this video. See you soon for a new interesting math topic.